Okay, so while some of you are going to join us, I think it's time that we kick off today's session. So we're super happy to organize this joint meetup between the Poznań chapter in Poland and Paris. So if you don't know us already, we would like to introduce our code of conduct. WiMLDS is dedicated to providing an harassment-free experience for everybody. So it means that we expect you to be super careful about the way you ask your questions or the vocabulary you choose when you use the chat part. We are all about sharing knowledge and connecting with each other. So let's be kind. And if you want to know more, the code of conduct is accessible on the GitHub of WiMLDS. And for today, as we are online once again, we would like you to switch off your video in order to have more bandwidth and to make sure that we have a pleasant experience together. If you can mute your microphone when you will speak, if you want to ask a question, please do so. We'll see. Either one of us will read the questions or we will ask one of you to read his, her, their question. And when the moderator will ask you to speak, please don't forget to unmute yourself. If you want to ask a question, we would like you to use first the chat part so we can combine all the questions at the very end, or you can raise your hand. If we get disconnected, don't worry, we will come back with the same link. If you don't know WiMLDS yet, our mission is to support and to promote women and gender minorities who are practicing, studying, or interested in machine learning and data science. And we are quite a big organization because today we have more than 62,000 members all around the world with 97 chapters within more than 30 countries. It's quite significant, and we are pleased that tonight we are joining forces with the Poznań chapters in Paris. So you'll see, we'll first have the pleasure to listen to Maria Ferlin, who will talk about how to detect waste with AI. Then we will listen to Oleksandra Vereschak, on how to evaluate trust in AI-assisted decision-making. And we will have an interactive session at the very end, but you'll see, you'll get the chance to ask questions after each presentation. If you don't know the Paris team, we are four. So you have Chloe on the left, Marie, and myself, and on the right, you have Natalie. We have been around for almost 4 years now. We are the third largest chapter in the world within WiMLDS. And so we are quite big on social media. We love to tweet, we love to share posts and knowledge on LinkedIn as well. So feel free to share the different links with your coworkers. And the team is also super happy to make some recommendations for you tonight. If you feel like it, on Netflix, you have 2 movies. The first one is entitled Coded Bias. So it's introducing researchers like Joy Bolamwini, Timmy Jebru, who works on bias in AI. It's super interesting. You'll also see Kathy O'Neill. And if you want to watch a movie or if you have kids around you, we recommend you The Mitchells versus the Machines. And you'll see it's a very nice movie about how technology is spreading and all around the world. And last but not least, we have a book recommendation. Kate Crawford, who used to be the leader within the AI Institute, just published a book which is called Atlas of AI. We strongly invite you to have a look or to buy this book. And now I'm going to let Agnieszka from the Poznań chapter introduce Poznań chapter.
All right, thank you, Caroline, a lot. Tonight is Basia online as well, together with me, a great part of Poznań team who is working with me since the early beginning in 2018. Basia is data science manager. So if you have any questions regarding running a business intelligence and data science project from scratch and dealing with terrible mess in data, she's the right person for you to contact. And when it comes to the other great part of our teams who couldn't join us tonight, there is Zuzana, who is a Python developer and data scientist, and she's currently fighting some fires at work projects, so fingers crossed for her. And Martyna, who is the data science and data engineering team manager with experience in microbiology research, and she currently is on her maternity leave, but she enforces us with her support. So yeah, that's the team, and me, I'm Aga. I highly recommend to all of you to reach out via social media channels with us and with Paris team, who I admit they are very, very active, and we are huge fans of their activity. And not to take too much time for introductions, let's go to our first speaker. But yeah, you could notice there was encouragement for tweeting and retweeting the content about today's meeting. So yeah, I highly encourage you to do so. And let's go to the first presentation by Maria Ferlin. She's a PhD candidate at Gdansk University of Technology. Her main research interest is around the machine learning in medicine, but tonight she's going to present you a slightly different topic, because that was her side project run together with WiMLDS Trójmiasto team and other associates, as she is strongly engaged in topics of using technologies for social goods. And yeah, Maria, the stage is yours.
Hello, everyone. Nice to meet you. My name is Maria Ferlin. As Agnieszka said, I am doing a PhD on Gdansk University of Technology. And today I would like to tell you something about the project called Detect Waste in Pomerania. Just in case you wonder what is Pomerania, it is a region in North Poland, and the capital of this region is Gdansk, where is our Women in Machine Learning and Data Science organization. I will tell you today what the project was about and what was our motivation. I will also present the whole team that was working on this project. And later I will tell you something about our database and our approach to solve this problem. And in the end, I will present our results and possible application for this system. So what is Detect Waste? Detect Waste was a 5-month educational non-profit project where 9 women were engaged to solve the problem of environment pollution. And the main idea was to use AI for good. So the organizers decided to create a project that will detect waste in images and in video. I don't know if anyone of you knows, but over 2 billion of tons of waste is produced every year. It's such a huge number that I can't imagine it. For example, an average European produces over 100 kilograms of plastic waste every year. Considering that plastic is very light, it is still a huge number. And if this trend continues, in 30 years, there will be more waste in the oceans than the sea creatures. And this is horrifying vision. So we as the team decided to do something good. We were working hard to create a system that will be able to detect waste in the various environments. Three of us were the main organizers. This is Agnieszka Mikołajczyk, Ewa Marczewska, and Magdalena Cortez. It was their idea to create that project. And they found mentors for us who are very helpful during this whole 5 months and answers all our questions and try to solve our problems. Our organizers also found partners for us who gave us hardware, who annotated us some data, and without them, we wouldn't be so successful with this project. So now let's move to our work, what we've actually done. Starting from the database. At first, we thought that we will use only the TACO dataset. It is a dataset that contains 1,500 images with annotation and 3,000 images without annotation. So here, our partner helped us and annotated these 300 images, but it was still not enough. So we started to look for other datasets. And as you can see, we found quite a lot, but they differ in many different ways. For example, the number of classes. Class is something like category of waste. There were some data sets that had only one category, like litter or not litter. And there were also data sets that had more categories. For example, in this TACO dataset, there were 7 main classes and over 60 subclasses. For example, the plastic bottle and the glass bottle. And we had to deal with this problem of so many different classes. The other thing was the purpose of this database. For example, one of them were more for classification task. It's when the image has its label like there is a trash in this image or not. And the other one were for detecting purpose. So in the image you have one object and you have annotation for this object. And you can also have much more than one object. The other difference between these data sets was also the background of this image. For example, some of them were taken indoor and the other were taken in the wild, for example, at the beach or in the woods. There were also some images taken underwater. So here you've got some examples of these images. As you can see, they differ a lot. For example, here you've got a really beautiful picture because it has plain background and all the objects are very visible and clear, and there is no problem to identify what there is. But for example, in this image, it is much harder because I suppose that no one can here say what it is. So this type of trash we annotated as whole, as a liter. As you can see, these pictures also differ in the sizes of objects and in the light condition, and it has some good and bad sides because if you have such a diverse database, you can make a model that is very universal. But on the other hand, it is really hard to train a model that will have satisfying results on such different images. So we had to do something to order these images. We decided to go with recycling rules in Gdansk. It's paper, metals and plastics, glass, bio, non-recyclable, and other. Other are non-typical objects or hazardous waste, like batteries, for example. These were 6 classes. But during our research, we found out that some objects in the image are not so clear. For example, they are partly degraded, or they are under some leaves, and you can see what there is. For example, when you are walking in the street, you can see the object from the other side. In the image, you don't have this opportunity. You can take the object into your hands. In the image, you don't have this opportunity. So we decided to take another class that was called unknown for these unidentified images. And this is how our database looked at the end. As you can see, it was very unbalanced. And we had a lot of representatives for metals and plastics, and very few for glass and paper. It leads to some problems that some objects may be later identified as metals and plastics, while they really don't. About different annotations, I've already said that in each database, we had to have different annotations and transfer them to our rules. Also, different background and different objects were a challenge. Interesting thing is that trash in Poland, for example, and in the USA look totally different because we have different companies, different bags, and it's not the same. So if you want to make a system that is very universal, you have to combine images from different parts of the world. So after getting this database, we decided to take a 2-stage approach, because after training our model on this database, we found out that our results weren't so successful. And we decided to, at first, detect an object in the image, and then later to classify it properly. The detection task took us quite a while. At first, we divided our team into smaller groups and train all these models on different architectures. We've also tested different data augmentations. It's a technique to enlarge the database by using, for example, rotation of an image, or by adding a blur. And in the end, we decided that efficient.dat D2 was the best network for our purpose. And as you can see, it is quite good in detecting objects in the image. Then there was a second stage. It was litter classification. Here we've decided to use also, but this one is dedicated to classification. Here also we've used different parameters so that we could use it for our purpose. And we've also take advantage of pseudo-labeling. Pseudo-labeling is a technique that allows us to use unannotated data. You will think how. You take some part of data that you have already annotation for, and you train your model. Then you put the unannotated data to a trained model and get some pseudo labels. In the third step, you take the pseudo labels and annotated data and train the final model. This step 2 and 3, you repeat until you get satisfying results. And this way you can use your unannotated data. So now, what have we achieved? These are our results. 75% mean average precision for detecting task, and 75% average accuracy for classification task. It is worth saying that it's not the same metric. So in detection and classification, you have two different metrics and you shouldn't compare it. So here you can see that we detect objects pretty well, and then the classification also works. On the other example, here, did you see that? I will show that again. It is something what I've told you already. Here you get a glass bottle, but it is classified as metals and plastics. And it is because of the unbalanced data set. And here we've got another example. It is also interesting that here the shoe was considered as a trash. And you can think that it is wrong, but let's wonder. We go to the shop and buy a bottle of water. It is obviously not a trash. If we drink that water, it can become a trash. But if we fill that bottle again with a water, it's still not a trash. So defining when something becomes a trash isn't so simple. So if you wonder where that system can be used, for example, using drones to monitor environment. When you go in the wild, you probably have seen some illegal trash dumps, and if we will be able to find them, we will probably be able to get rid of them. Also, another example to use it is automating the recycling process. And nowadays, it's rather done manually, but probably in the future, it will be possible to categorize the waste automatically. All our work is available on our website, detectwaste.ml, or in our GitHub repository. So if you are interested in more details, you can visit this website. We've also managed to write an article about it, and it is also publicly available. Thank you very much for your attention, and if you have any questions in the end, I think it will be time for it. Thank you.
Can I ask a question? This is Natalie. You mentioned that there are two metrics, and the metrics are not the same, the detection metrics and classification metrics. Can you explain a bit more about this aspect?
Yes, of course. I will go there. In the classification task, it is pretty simple because you can, if the prediction is good, it is only the matter if the prediction is good or bad. But in the detection problem, you have to take into consideration also the size of the predicted bounding box. Yes, here this square. And how does it overlaps with the proper one. And this metric is counted it is much more complicated. Yes, in classification task, it is only the way, is it good or is it bad? But here you have to take into consideration the place in the image.
Okay, thanks a lot, clear. Mm-hmm. I think there was a question in the chat.
Yeah, there is one question, which is, I'm curious about pseudo-labeling. Is there any human in the loop approach where you checked that pseudo-labels aren't garbage?
No, in our approach, there were no human during this pseudo-labeling. There are two ways. You can add human to this approach, and in this step, when you have some pseudo labels, you can give it to a human to make a proper label if there is anything wrong. But in our approach, we had so many images that we didn't have any force to do this supervision under this pseudo labeling. So I think that is part why our classification results aren't higher, because here, as you can see, maybe it is some of these labels may be wrong, and it is something that you have to accept.
Excellent, Maria. Some of you asked if the recording would be available. It will be on our YouTube channel, and it will also be on our Medium page. And just for you to know, we got a problem with the recording at the beginning, so now it's working. Actually, Maria, just for you, most of your presentation has been recorded. So if you don't mind, you can stop sharing your screen so that Oleksandra can jump on stage. You can go ahead. And again, please write your question in the chat part if you have one. And good luck, Oleksandra. The floor is yours.
Perfect. Thank you so much. Thank you, everyone. Good evening, bonsoir, and dobry večer. Thank you for inviting us. Thank you for having us. And thank you for everyone taking the time of your day to come, to join, to listen Maria's and my presentation. It means a lot, and it's an exciting opportunity to be able to get new perspectives about different projects. Where else could we have an opportunity to do so? So as you might see from my Zoom background, I'm currently located in a university. It's called Sorbonne Université. It's located in Paris, France. That's where I'm doing my PhD in human AI interaction. I'm doing my PhD in one of the robotics lab of Sorbonne University under the supervision of Gilles Bailly and Baptiste Caramio, thanks to the Sorbonne Center for Artificial Intelligence and LabX Smart. That's about the background, about what we're going to be learning today. So the slide in front of you that you hopefully see might have already spoiled that the next 18 minutes will be dedicated to understanding how to evaluate users' trust in AI-assisted decision-making. And I know I used 5 nouns in a title, so it sounds a bit complicated and heavy. So before I even start answering this question I posed here, I will actually go ahead and break it down for you so that we're all on the same page on what I'm actually asking here. So that's why we'll start with a little bit of context. And first, we'll look into what is AI-assisted decision-making. What do I mean by this phrase? Let's imagine a general scenario. There is you, and you're a user of a system, and you have to make a decision. You have to choose between A or B. And there is a system which is powered by artificial intelligence that can analyze a lot of data. And based on this data analysis, it can give you a recommendation about your problem that you have. But then, even if the system gives you a recommendation, it is still up to you, the user, to decide, yes, okay, I'll go with B, or no, I will go with A. So this is what, in general terms, AI-assisted decision-making is. What context it can be used? In plethora of contexts. The most widespread are, for example, clinical decision-making, like in this example for predicting a cancer grade, and sometimes it can be also used for assigning medical treatment, which medical treatment will work better for a certain patient. Or it can be used in hiring decision-making, that is understanding which candidate is a better fit for a company, which one to hire, which one not to hire, which one to invite for the second interview, which one for not. But there are many other contexts like university admissions or financial decision-making where AI-assisted decision-making is in place. So now we are more or less on the same page what it means what it means to be AI-assisted decision-making. Now another part. I'd like to briefly mention what it means to evaluate systems with users. So when you're designing a system, it is useful to get insight about what the potential users might think about it. So is it easy to use? Is it useful for their task? Maybe if it's fun to use, it can also be the case. Or if it's trustworthy. You can also evaluate how the system makes users feel. So after using the system, do users feel annoyed or satisfied or relaxed? Or did they actually trust the system? And to measure this, to be able to evaluate, usually you let the system and the user to interact between each other. And then after this interaction, you gather users' feedback in various ways, for example, asking some asking them to fill some questionnaires. So these are questions where you would usually agree or disagree from 1 to 7, for example, to a certain question. Or you can talk to the users and have a sort of interview to understand their perceptions of the system and how they feel, or also infer some of the things I mentioned about from the ways users interacted. So for example, what they clicked on, how many recommendations they accepted, how many recommendations they followed, etc. Where they looked at even, for example. So that's more or less how what evaluating a system with users is. So let's combine then everything together, what I mentioned in the question I asked in the first slide. Evaluating users' trust in AI-assisted decision-making. Why specifically, out of all the different things we can evaluate with the system, why trust is important, and why is it actually a topic even for AI-assisted decision-making? Why the focus on trust? Well, the systems I talked about, the one that assist decision-making, are more and more present nowadays in the domains where a wrong decision can lead to a consequence that can be damaging to someone's life, health, finances, career, etc. So something can really go wrong if we make a wrong decision. Then the human AI community decided that it is essential for users that interact with these systems to have appropriate trust in the output of the systems, to be able to inform their decisions, to be able to use the systems efficiently. And to do that, it means that the systems, AI systems that assist decision making, have to be trustworthy. And the community gathered together and we started thinking of what it means for a system to be trustworthy. And there were multiple guidelines for trustworthy AI designed. And one of them could be the one designed by IBM, for example, so that the system is fair, so that it's transparent, so that it's explainable, etc. So we're building a system, we're using guidelines to make it trustworthy. However, there is one but. Just because the system is built according to trustworthy guidelines, it doesn't mean that the users will trust it. Okay, so if it doesn't mean that users will trust it, we need to understand whether they will actually trust it. So that's why we need to evaluate users' trust to see if actually we succeeded following their guidelines for making the system trustworthy. And perfect, we have a clear goal, evaluate users' trust. So let's do it. We already know how to do evaluation. We'll let the users interact with the system. We ask them a couple of questions about their trust, and that's it. Except when it comes to trust, it's not that easy. Because trust is a very subtle theoretical construct. It's not a height that we can measure with a ruler. It's not blood pressure that we can have an electronic device and measure. It's a bit more complex than that, right? We cannot really see it. If we cannot really see it, we can still, well, I told you, we can still ask participants a couple of questions. But what kind of questions do we ask participants? Do we go ahead and say, hey, did you trust the system? Yes or no? Is it enough to evaluate the system? Or we try to not to be as direct and ask them multiple questions, trying to infer what they feel? Or if asking questions is so complicated, do we just abandon the idea of asking questions and we try to infer if they trusted the recommendations of an AI system based on how many times they accepted their recommendations and how many times they didn't accept recommendations? And also thinking about when evaluating trust, do we just give a task to a user and that's it, and then ask questions? Is there anything else needs to be in the environment so that we get good quality of the data? And so once you start thinking about how to actually evaluate trust, there are so many different questions that start raising, that start to be brought up, and to which there are no guidelines or no checklists where you can say, where you can look and say, ah, okay, so I need to make sure there is this in my study, that in my study, and I need to ask this and that question to measure trust. There is no such guidelines. So that's why, in order to understand what is actually trust and what is important to include in a study to evaluate trust, and what kind of measures can we use to evaluate trust, I tried to find answers to these questions. And to do so, what I did, I looked at human AI trust literature, at the studies that study trust in human AI, and I looked at how they define trust and what methods they use to evaluate trust and how they conducted the evaluations to spot if there are any common patterns between these papers, right? So I did that. I found my patterns. Then I went to another type of literature, human trust, and I looked at their patterns, and I compared the two trends in both of the communities to see if human AI trust community can improve their understanding and the methodology they're using. And why I exactly used human trust literature as a reference? Well, because trust originally as a concept was studied between humans, not at first between the systems. So that's why the literature on human trust is much more advanced, and their discussions are much more fruitful, so we can really learn from them. So I did that, and the rest of the presentation, I will explain to you what makes trust and what makes it different from other theoretical constructs, what exactly we need to include in our experiment to get the good data about trust and not other theoretical constructs, and what to look for in trust measures that we need to choose. So let's start with the first question, the definition, so that we exactly know what we're talking about. There are many definitions of trust. One of the most complete ones is this one. Trust is an attitude that an agent will achieve an individual's goal in a situation characterized by uncertainty and vulnerability. Again, a lot of nouns, a lot of words. I will break it down for you, no worries. And I said that this definition is most complete because it actually combines three most important elements that make trust, and that make it different from other constructs. So these elements are, first of all, that trust is an attitude. What does it mean? What is an attitude? Well, attitude is evaluations of objects, ideas that you form in your head. What does it mean? For example, Sarah finds spiders cute. So Sarah's attitude towards spiders is that they're cute for her. Or David has mistrust and annoyance towards telemarketers. It's his attitude towards telemarketers. And why I'm spending some time here is because I would like to underline that attitude is different from a behavior. I know it might be a little bit esoteric and theoretical, but I'll give you another example. Let's say we know that Sarah finds spiders cute, and we know that Sarah's behavior is that Sarah would never kill a spider. If we just looked at Sarah's behavior, could we infer from this behavior that Sarah's attitude is that Sarah finds spiders cute? Yes. But is it the only attitude we can infer, and is it the attitude that explains the behavior fully? Here the answer is no, because Sarah would never kill a spider, maybe because She's superstitious, not because she finds spiders cute, or maybe because she is so afraid of them that she doesn't want to be near them. That's why she would never kill them. And in this example, I really want to highlight that behavior does not equal attitude, even if sometimes behaviors can help us infer attitude, but the equal sign does not hold all the time. And the same goes with the David example. David can mistrust and be annoyed by telemarketers, but yet he can always listen to their phone calls because maybe he's too polite to say no, or maybe he wants to annoy them by wasting their time. So by these examples, I would like to underline that trust is an attitude, and that means it's not a behavior. And it means that by considering how many times users accepted a certain recommendation, we cannot always infer if users trusted that recommendation. Another important aspect of trust is uncertainty and vulnerability. That is, for trust to form in our cognition, we need to be in a situation of vulnerability. That is that if we make a wrong decision, there is an undesirable outcome, the outcome that we don't want. What I mean by that? Again, 2 examples. If I accept this recommendation and because of this recommendation, I assign a wrong treatment, this might have negative consequences on the patient health. We are in a position of vulnerability because there are undesirable outcomes. Another example, if I accept this recommendation and this recommendation is about how many jelly beans are in the jar, and if I'm wrong, the worst case scenario, I'm wrong and I'm upset about it, but no one is hurt, no one's life is at stake, no one's money is at stake. So in this case, we're not in the position of vulnerability. So if in these both cases, in this both tasks, after this kind of decision, we will ask participants about trust in the system or trust in the recommendation. In the first case, according to the social cognitive theory of trust, because the person was in the position of vulnerability, in their cognition, trust formed. So if when they're answering the questions about trust, we will get the good data about trust. In the second case, however, because the user was not in the position of vulnerability, trust didn't form in their cognition. It means even if we're forcing the user to answer questions about trust, even if it doesn't really make sense, we're most likely to get the data about confidence. The difference is that in the first case, the users are in a position of vulnerability and they are kind of sharing responsibility with the recommendation with the system. And in the second case, there is no vulnerability, no responsibility. So vulnerability is important not to get the data about confidence, which is a related construct, but it's still not trust. And lastly, to trust someone or something, we need to have positive expectations about that person. Otherwise, it just will be mistrust, distrust that we're measuring, not trust. So what is trust? You don't have to memorize the definition by heart, but you have to remember that it's an attitude. That means it's not a behavior, and that while thinking about a study, we need to make sure that our participants are in a position of vulnerability and that they have positive expectations. How to include these 2 elements in a study? Well, first of all, vulnerability means including some outcomes in the study that participants care about. But the study is a study. It's not real life. Yet still, it's still possible to induce this element of vulnerability by introducing outcomes. The outcomes can be virtual and real. Virtual if for every wrong decision you tell participants they're losing some game points, for example, if it's a gamified study, or their virtual character in a game dies or that their virtual teammates die. But since we are paying participants, sometimes to participate in our studies, we can also penalize them with paying less money if they made wrong decisions, for example, or making them do more tasks, or for example, wait for 3 minutes if they make a wrong decision. And based on some experimental experience, this is the worst punishment for participants, to be still in front of a computer for 3 minutes. And also about positive expectations, first interaction and first introduction matters, not only with people, but also participants. And also systems. So either in the instructions, the way you introduce the system, try to state its relevant accuracy and that it was used in similar cases, or if it's possible, try to make the first recommendations trial error-free if you have a very controlled experiment. But if it's not possible and it might deceive participants or set unrealistic expectations, the first decision points, you might just want to discard them from your data because this might be just the calibration points for the participants. And lastly, we come to measures of trust. I'll go over them briefly, but feel free to ask me questions about them later. One takeaway is that, remember, trust doesn't always mean behavior, but it doesn't mean that when you're running a study, you should discard the data about how many recommendations participants accepted or rejected. It's still very interesting data. Just from this data, the most important thing is not to say, because participants followed 15 recommendations out of 20, it means that participants trust the system. That would be a tempting conclusion to make, but a bit misleading. There are questionnaires that you can use to evaluate users' trust. They can be single item, so a direct question. But as of now, the state of art says that we're not quite sure if they're actually a good way to measure trust. And there are questionnaires with multiple questions which are carefully picked and crafted and validated to make sure that they measure trust. And there are many of them. Just in human trust, there are 200 of them. And I'm sure in human system trust, there would be as much. So try to choose the questionnaires out of these hundreds of questionnaires that ask questions about positive expectations and willingness to accept vulnerability. And here are some of the examples of these questionnaires. The problem with the questionnaires is that they're very, very, very long. So if you want to really measure the changes of trust, you cannot really ask them after every decision participants make. So the current state of art of measures of trust is that there are multiple methods. They measure trust to a certain extent. So for the sake of getting good data, we need to use them together to triangulate them, understand the relationship between them. And also, there is a big need to find a measure that is quick to use, and so that we can really measure the changes of trust over the time, because trust is not constant. It starts from one point and then it can raise, it can reach a plateau, it can decrease after an arrow, for example, and then it can start growing again. But there is more, of course, about measures of trust that I can say. And I would be happy to discuss that with you afterwards during the Q&A session. So the main takeaway message is that trust, when you think about trust, think that it's not a behavior, and think that participants need to be in the vulnerability and positive expectations environment. For that, task outcomes and first interactions are important, and then there still needs more work to be done for trust measures currently. These results I presented, I have to mention, they're part of a paper that was recently accepted for a CCW conference. The paper should be out soon, so don't hesitate to find me on Twitter or LinkedIn, or shoot me an email if you want to discuss more about this topic. And thank you so much for your attention. Thank you for your emoji applauses.
So there's a lot of comments saying it's very interesting. And Agnieszka is saying, I've just made a resolution to not complain about behavioral metrics I have to use in daily work. I am impressed by the conceptual framework needed to operationalize it. So it's a lot of positive feedback. I can't see any question yet. So if you want to ask a question, feel free to open your mic.
Yeah, if you don't mind.
Go ahead.
Yes, so thanks a lot, Alex. I'm very excited to discover your work. We've talked before, but I didn't know what you were talking about. I find your work very interesting, and it's anchoring in social psychology. The distinction between attitude and behavior is very important. What I'm a little bit worried about is that is trust the ultimate measure that you want to emphasize in recommender systems. I'm explaining myself is that sometimes you will want the algorithm will be right, but the user will not follow it. That's algorithmic aversion, and of course you don't have trust. Sometimes, so that is to say, at some point the user cannot be trusted either. And so should we not also focus at some higher level on what is the performance of the combination of the user plus recommender system, rather than just does the user trust the system?
Yes, Thomas, thank you for coming to the talk, by the way. Happy to discuss more with you. Very good question. I have to make the comment that you're absolutely right. And then the ultimate goal is not to increase trust or study trust. The ultimate goal is to help users calibrate their trust, what is also in literature called have appropriate levels of trust. And this is exactly what you mean by have this combination of users' trust, but also systems performance. So appropriate trust, how it is defined in the literature, it is users trusting the right recommendations and users being averse or not trusting, not accepting the recommendations that are actually wrong.
Okay, thanks. That's very enlightening.
Yes.
We could have longer conversations, but I don't know.
Avec plaisir. But it's true what Thomas made an interesting remark that in the literature, sometimes there is this narrative of increasing trust, increasing users' trust, and it's a bit of flawed narrative exactly because we increase very high levels of trust sometimes can be overproductive. If the users are not able to detect that the system is giving flawed recommendations, this is counterproductive, then that increases the performance of the user. So,
so you have complacency bias also.
Exactly. That's exactly what it's called. So you should, we as a community should work on appropriate levels or calibrated levels of trust, what they're called sometimes.
Oleksandra, I guess that afterwards you will remain available if anyone wants to write to you to ask questions, right?
Oh, absolutely, yes.
Good. So far so good, because I can't see any question in the chat part. So I think we can wrap up the session and thank our super interesting speakers for their time, for being online with us. And I would like to say thank you to every French person who was with us, because today we could have been on a terrace and you chose to expand your machine learning knowledge. So thank you. Have a good evening, everyone, and we will share all the content on our Medium page and YouTube channel very soon. Stay tuned online. Have a lovely evening.